you're official. Fractions. Thank you. One person, right? Two people. Okay, relations versus functions. Sometimes this is taught at the beginning of algebra, near the beginning. Sometimes it's taught in the middle. Sometimes it's taught in the end. It's actually a really important concept. And it's, to be honest with you, it's taken me about 50 years to realize how important this concept is. Because as you move forward, most of higher level math deals with functions. When you move into calculus, you're dealing with functions. So what's the big deal? Why functions? What are functions? So you have to first understand what they are, and then you'll understand, hopefully, at least, I'll share with you sort of my awakening of why they are important versus relations, okay? And so it's important. There's a thing called function notation as well, which you will start to see more and more. Instead of seeing y equals 2x plus 3, you'll see f parenthesis x parenthesis equals 2x plus 3, which is usually pronounced f of x. Or you might see g of x, or you might see h of x, or you might see h of t, or g of t. Those are all different ways to denote that it's a function, okay? And so we're going to talk a little bit about kind of what a function is today, and how do you determine whether something is a function or something is not a function. Okay, first of all, if you had, let me think, if I had a graph, and I had a dot here, and a dot here, right? That's all over. Are those related? I mean, compare that to something like this, where I have, are these related versus these? No, there's no, like, there's no order to this relation, right? But they are related. They are, there's always a relationship between dots, right? There may not be any order or any calculatable pattern to the relationship, right? But there's still a relationship, right? You can wear plaid pants and plaid shirts, right? But that's not cool, right? Hopefully you've been taught that way.
It's not.
Right? It's not cool, right? But they have a relationship. They still have a relationship together, right? Yeah. So this, though, has not only a relationship, but it has a pattern. It has something that is valuable. It's something that's dependable. I can depend on the shape of this particular relation, of all these points. Does that make sense, you see? This is a function. This is not a function. A function is dependable. We can create a pattern with a function that we can depend on, that we can expect. And so we can, if I wanted to know, what is y out here, I can pretty much, guess that it's going to be right here. If my x is out here, my y point would be up here. I can pretty much guess that this would be down here. But if I wanted to guess what is the point here, when I go to the x here, where's my y? Not a clue, right? Not a clue. It's not very dependable. I can't really use it. So this is a relation. This is also a relation, but it is also a function. Also a function. Does that make sense to you guys? Like, a banana is a fruit, right? But a fruit is not necessarily a banana, right? Relation is the bigger term. It's like the fruit. Function is like the banana, or the orange, or the apple, or the pear. It's one type of relation, okay? The beauty of the function is that you can depend on it, okay? So what you've been dealing with all these 2 years now has been functions. You've been talking about how to graph straight lines, which are functions, how to graph parabolas, which are functions, how to graph square root equations. I think have you guys learned those? Have you learned those?
Yeah.
Square root equations, and some of you at least have, I think. What else is there? You know, absolute value equations, right? You know, they're all functions. Now, the question, yes?
What did I miss?
Everything.
Sounds good.
Yeah, so really what I'd like you to do is watch the video. It's just, you know, at least the parts that you, the beginning part, because you missed the beginning part. I'm sorry?
So I can just watch the video.
You what?
Because I was here, I'm just going to watch the video.
Yeah. That would be helpful. And just so that you get an understanding, because I was explaining to them, to everybody, before you guys, while you guys were away, that it's taken me 50 years to understand why functions are important. I've never had a teacher explain it to me in a way that made sense to me. It's like, big deal. What's the difference between a relation and a function? This is a relation. They're both relations. Everything is related to each other. We're all related in some way. All of us in here, all the people, all the beings on this planet are related in some way. But we may not all be human, right? We may not all be straight. We may not all be gay. We may not all be happy. We may not all be sad, right? There's lots of different categories within, you know, the relationships, right? One type of relationship is a function, and a function is something you can depend on. I know that in this case, I know this function looks like, oh, it's a straight line. It looks like I can depend on it. If I wanted to find the point out here, I could just follow that line up and find out where my y would be. I can depend on it. Here, I can't. If I wanted to figure out where's my y and when my x is over here, not a clue. There's no pattern, right? Nothing I can depend on. So, so now the question is, how can you tell if something is a function? So let me write this down. With graph, okay, so this is the question. How can you tell, because we're going to be talking about this particular question, so be sure to write this down in your notes. How can you tell if something is a function? How can you tell? So first of all, by graphing. All right? So this is the first way, graphing. And there's a thing called the vertical line test. Okay? You guys with me so far? Making sense? All right, so here we go. We've got a graph. I just realized I need a vertical line. Yes. Okay. Lovely, perfectly drawn graph there. So if this is my y and this is my x, and I have a straight line, and I want to know, is that a function? All right. If you take a vertical line test, actually, let me before I even show that, let me define how you know. The definition of a function. This is the definition of a function. Sorry, I'm sort of winging this because I only just found out that I was teaching everybody, and I wasn't going to teach this class until tomorrow, so I was going to prepare it more. So I'm winging this a wee bit, but I think it's going to be still good and helpful.
Doing great.
Great, thank you so much. Definition of a function. Okay, for every x, this is really important. If you understand this, it'll be a piece of cake. This is the key to everything I'm going to be talking about today. For every x, comma, there can be only one y.
We learned this last year.
Okay, yes, you did learn this. We talked about it briefly last year. We had you guys do a reading in a textbook. But I just want to be sure that not everybody has learned it. I don't think Nate's group learned it. Well, they might have. I don't know. I can't remember. But this is like a really key important thing. So think about it. If you use for graphing, if you used a vertical line test, and I come across here, and here's my line. I'm trying to figure out, is this line a function? Okay, I come vertically like this, and I hit a point on this line. Is there is there one place or two places where this vertical line hits hits the graph point? Okay, so for this x right here, can you guys see this? So for this x right here, there's only one y, right? For this x right here, there's only one y right here. For this x, there's only one y here. For this x, there's only one y. For this x, there's only one y. For this x, there's only one y. So yes, this is a function. You see that? There is no place where I have two y's for every x. Okay, so that's definitely a function. So let's try a different shape. Let's see what else is a function. So we now know that a straight line is a function. That's interesting. So, okay, so we're going to just list our functions that we have here. Functions. Okay, straight lines. Those are definitely functions. Okay, and then let's try parabolas. Okay, there's our parabola. We're going to try. Now remember, a parabola is always getting bigger as it goes higher. It's always extending out. It never starts to go straight up and down. It never becomes totally vertical. You know what I mean? It's always expanding. Therefore, it's going to go forever this way, right? It's going to go forever that way. Now, as I come along here, it's not hitting anything. Now it hits the line here, okay? For this x, there is one value of y. For this x, there's one value of y. For this x, there's one value of y. For this x, there's one value of y. For this x, one value of y. Yes, this is a function too. Parabolas are functions. Parabolas. And I'm going to put the word vertical in here. Okay? Now, let's try another shape. Okay, that vertical word after the parabola is kind of important. So watch this. Now we're going to do another shape. This would be easier to just redraw this, wouldn't it? Boom. Oh, okay, this is my x, this is my y. Okay, now we'll do another parabola. Beautiful. Okay. Sort of. Okay, so we're going vertical line again. Vertical line. For this x, there's nothing. For this x, there's one point right here. That's the way that I drew it. It didn't look right. You got it? But there's one point. Yes. So far we're okay. But whoa, as soon as I go past that one point, for this x, I have two y's. Immediately. I don't even have to go further. I know immediately that that is not a function. Immediately, right? Immediately. It's not a function. All I have to find is one exception. I don't have to find 10 exceptions or an infinite number of exceptions. One exception, it is not a function. Okay? So I am going to say that's not a function. So a parabola that's horizontal is not. Okay, that's why I said the vertical. It can be happy face or sad face. That's fine. But it can't be a side face or whatever. Right? It can't be one of those. Okay. Makes sense, right? It's pretty straightforward, really. So what about this?
No. That's a relation. It's just like two parabolas.
It's a relation. Now, in some ways, this is a dependable shape, right? So I can use it, it's dependable, so that doesn't quite fit my definition of function when I was saying that before. But as you see here, for this x here, there's only one value of y, but as soon as you go past that, there's a lot of places where there is two values of y for every x. Does that make sense? Therefore, not a function. Now you will be dealing with circles, actually, in Algebra 2. Depending on where you go. Next year or the next year, year after that, yeah.
Can a function be something like that?
Okay, great question. Okay, so let's try a different shape.
Not there.
Let's try a different shape. What if I have this? What if I had can that be a function?
Yes.
Yeah, absolutely. It's just a bunch of parabolas strung together, right? So it might be a sine function or a cosine function or something like that, where you actually, you'll get into those in Algebra 2 and, or maybe not Algebra 2, more trigonometry, probably. But yes, look, for every x there's only one y, all the way across. This vertical line thing is so valuable, so helpful. All right, so now, so that's graphing. We've covered graphing. What about a rectangle? Would that be a function?
No.
What about a square? What about a triangle? No, all of those would not be, okay? So right now, we've got straight lines, parabolas. What about, one more. What about a square root equation that would look like this? Yeah, it doesn't, it's half of a parabola. Because it doesn't have this side, it is a function. If it had this side too, it would not be a function, right? Does it make sense? Right? It is a function now because for every x, there's only one y. One y, one y. So we know, what did I call that? Radical functions, radicals are. And then how about one more? What about this? What kind of function is this? Absolute value. It's not a parabola, it's a straight line and then it bounces off into a straight line. It's an absolute value. Is that a function?
Yeah.
Absolutely. Yeah, function. So what is that? Absolute value.
Gary.
Yep.
Absolutely.
The absolute.
Oh, yes.
Absolutely.
Absolutely. Okay.
That was great.
So now,
Absolutely fabulous.
so now let's look at this. Okay, we've talked about graphing. Let's say you have, where's my sheet? Let's say we had a table, and I'll do a table in two different ways. The table, a T-chart, right? X and Y. Let's say I have, 0, 8, 10, 2, and 5. And then I have 1, 6, 3, 8, 4. Is that a function?
Yeah.
Why?
One x for every y.
There's one y
For
for every
every
x, right? Is the way, okay, so now what about this one? X, y, okay, 0, 2, 8, 4, 6, 2, 1, 6, 9, 4, 3, 5.
No,
No.
because the 2 has 2 lines.
The 2 has not only a 6, but also a value of 5. Immediately that tells me that for the x of, when x is 2, there can be two values of y. That is not a function. This is a function, yes. This is a function, this is not, no. Because there is a repeat in the x's. And we're going to talk more about this tomorrow. But the x's are called the domain. So I'm going to just write that down here. X's are called the domain. And the y's are called the range. Okay? So when there is a repeat in the domains, 2 and 2, immediately I know that it's not a function. There's no repeats here, therefore I have to assume it's a function. I'm guessing somehow function is going to be dependable somewhere. It's going to make sense somewhere, right? If I see the grander scheme of things. Right now I'm only seeing a tiny little piece of it. But that's okay, it's still a function, because there's nothing that violates the rule for every x there can only be one y. Now sometimes you will see a t-chart that is not not vertical, but it's horizontal. And I don't know what they call them, t-chart, box charts, I don't know what they are. I don't usually do these, but, you know, so if I had 2, 8, 10, 8, 0, 4, 6, 9. Function or not a function?
Yes, function.
Yeah.
No, because the 8.
Yeah, the domains are what you're looking at. It's only when you have these kind of things, it's only the domain that you're looking at. Right? The domains are the x's. So 2, 8, 10, 8. There's an 8 and an 8, and they both have different y's. It is not a function. Does that make sense? It makes sense, right? Pretty simple.
Well, if they both have the same y.
Oh, great question. Let's try that one. Okay, so let's say we have x, y. Okay, so oh heck, let's just do this. Is that a function?
Yes.
Yeah.
Why?
Because there's one y for every x.
There's one y for every x. 1 does not have any other value of y than just the 4. 0 does not have any other value of y than just the 4. 2 does not have any value other than 4. Right? It would be a problem if I had done this. I said 2, 5. Then it would be a problem. You see what I'm saying? Because then the 2 would have a value of 4 and a value of 5. Say it again. What was the question? If it was 2, 4? Well, then that's sort of just the same thing. So in that case, yes, that is still a function because the 2's have exactly the same. I mean, it's the same number, right? Because there's no difference. It's just like they just repeated that one, right? But yeah, then that's still a function. Okay, what if it's written like this? Okay, so that was a data table, right? Basically, a data table. Now, what if you get it in sets? Let's try sets. Now, sometimes you'll see set notation says this. That whenever you see this bracket, brace, brace, bracket, bracket, brace. I think these are called braces. Whenever you see a brace like this, oftentimes it's denoting a set, a group of points, or a group of something. Okay? And in this case, let me just be sure this is on the homework. Yes, it is. Okay. In this case, I have a set of coordinate points. So I've got 2, 4, 3, 8, 1, 5, 3, 2. Is that a function?
No, because
There's 8 and
There's
2 are
three,
different. And then
Right, so all you're looking at, just make sure you're only looking at the x at first. The domain, 2, 3, 1, 3. Oh, there's a repeat of 3's. So now we look at the y, 8 and 2, 2 totally different values of y. Therefore, it is not a function. Had this been a 5, then we would have been fine. Then it would have been a function, right? Make sense? Okay, great. So let me just quickly peek on here and make sure I'm not forgetting something. I don't think I am. Okay, one last thing before we're done. So a a lot of times you will see this. Well, you will see f parenthesis x.
That's just the function of x.
And all that stands for is the function of x, right? Whoops. Of x. And think about it, it makes sense. If when we do a t-chart for an equation, we're trying to graph it, and you do a t-chart, what is the value you always come up with in your brain? The x or the y? The x's. These are the ones. I usually do for a straight line, I'll do 0, 1, and 2. Remember this? Right? So I am totally choosing my x's. I mean, I don't care. I mean, I could choose 0, 1 million, and 2 billion. It doesn't matter. I can choose anything I want. Y is dependent on what I choose for x, right? So in an example like this, y equals 2x plus 4, well, y depends on what I chose for x. I chose for x 0 in this case. So 2 times 0 is 0 plus 4. Y would equal 4 when x is 0. So I put that there. Y is dependent on x, right? Make sense? X is not dependent on y. Y is dependent on x. So y is the dependent variable. Dependent variable. And x is the independent variable.
We definitely were.
Yeah. My feeling is that a lot, there's parts of it you probably didn't learn too well, which is domain and range, which we're going to move into this week more extensively so that we understand that. But I have to talk about this first because this is the foundation of all this. Now, plus you learned it basically from the book, and I don't like the book that much. Now, the thing is, y is a function of x because it's the dependent variable. Y is a function of x. Does that make sense? All right, therefore, I can write an equation like this. F of x is equal to 2x plus 3, and I can say graph it. Oh, great. That's my y-axis, this is my x-axis. Y is the same thing as f of x. I could make this f of x if I want. I could put f of x. Sometimes you'll need to because you'll have weird things, other things that are kind of weird. You have to keep them separate. But up 3, 1, 2, 3, put a dot. Up 2 over 1, put a dot, draw your line. Whoops. You got the idea. Okay. But, right? So, very easy. So whenever you see f of x, you can think y. It's totally the same thing. Make sense? Right? It does not mean some variable f multiplied times some weird variable x. It does not mean that. But if one of the benefits of this is if I could say, if I have this, I could say find f of 5. So what would I do?
X is 5.
So f of 5 is equal to 2 times 5 plus 3. So 10 plus 3 is 13. So f of 5 is equal to 13. Did I do that right? F of 5 is equal to 13. Now, the homework tonight will have different things. Sometimes you'll see, like I said, you might see g of x, or you might see h of t, or you might see, sorry, I don't know, what else are there? W of a, right? They could all be functions. And eventually, as you move into Algebra 2, you're going to be talking about functions of functions, which gets a little more complicated. But that's why they often label them with different numbers or different letters. You see?
Wait, so would f of 5 equal 13? Would that be your answer?
Yes, f of 5 is 13. All this is saying is when I say find 5, find the function of x when x equals 5. That's what it's saying. Does that make sense? Find the function of x. In other words, find y when x equals 5. That's all it's saying. So I could put y equals 2 times 5 plus 3, y equals 13, or I could put f of 5 equals 13. I think most teachers prefer, since if they give it to you in the f of x format, most teachers prefer you to give their final answer in f of x format. So f of 5 is equal to 13. F of 4 was 8 plus 3, 11, right? F of 0 would be 3, right? Make sense? Okay, so that's it. So homework tonight is practicing, the first 2 pages is going to be practicing your whether something is a function or not. And then the last page is actually practicing inserting, finding f of x or g of x or h of t when they give you what x is, right? And some of them are a little funky and weird. Do your best, right? We'll just see how well you guys do. Okay, so that's it. I did. The stuff the video. Were you out? I need to collect them.